over 242. You're good. I think I might have some extra copies over here. Yes, I have it right here. So we're trying to simplify this complex expression. Now we need to see what we need to multiply the numerator, or multiply the whole thing by to get the fractions to simplify out. Well, for the top, we would need x minus 2. Well, for the denominator, or the bottom part of the fraction, we would need x plus 1, and we would also need x. Because since all three denominators have different things, we need all three of these here. Then we multiply this out, we multiply with the numerators. The numerator would be 16x times x plus 1 times x minus 2, all over x minus 2. Our first numerator in the denominator would be 4x times x plus 1 times x minus 2 over x plus 1. And our last one would be 6x times x plus 1 times x minus 2 over x. Now we would cancel out or simplify our top and bottom, x minus 2 and x minus 2. Here we'd have x plus 1 and x plus 1. And the last one would be x and x. Now the numerator, we're left with 16x times x plus 1. Our denominator, we have 4x times x minus 2 plus 6 times x plus 1 x minus 2. Questions on this here? Now with our denominator, we need to distribute this out. 4 times x is going to be 4x squared. 4 times negative 2 is negative 8x plus. Our plus sign in the middle is going to keep us from doing that. If that had been a multiplication, then yes. Now we have to distribute out x plus 1 and x minus 2. So our x times x is x squared. X times negative 2 is negative 2x. 1 times x is plus x. And 1 times negative 2 is negative 2. Now we do need to combine our like terms in this set of parentheses here. So we'd have x squared. Negative 2x plus x would be negative x minus 2. Now at this point here, we still need to multiply out or distribute the 6. Or 6 times x squared would be 6x squared. 6 times negative x would be negative 6x. And 6 times negative 2 is negative 12. Now at this point here, we can combine like terms. Our 4x squared and 6x squared would give us 10x squared minus 14x minus 12. Now there is a greatest common factor of 2. Now, unlike with our equations, because in an equation we can divide it out of everything and remove it completely. With factoring, we have to actually bring it out front. And we get this here. Now, one nice thing is our 2 over 16 would reduce. 16 over 2 is going to be reduced to 8 over 1. Now, we do need to see if the denominator, 5x squared minus 7x minus 6, will factor. And it will. We'd have plus and minus. 5x and x. 3 and 2 for our 6. And we can check and make sure this is the correct factors for the denominator. 5x times negative 2 is negative 10x. 3 times x would be plus 3x, giving us our middle term of negative 7x. And since nothing else is in common on top and bottom, that is our final answer. Question on this here.
You don't put the 2 at the beginning or no?
2 over 6 or 16 over 2.
So it cancels out.
So this here, because we have the multiplication now, those will reduce. Because really we can pull it off to the side and say 16 divided by 2 is 8 over 1. The 8 goes to the numerator, and we put the 1 on the denominator, but we don't have to write it in because 1 times our 5x plus 3 is the same as just 5x plus 3. Questions on this here? All right. I believe this is the one we finished off yesterday with. Yes? We're on the next one. Yes. Okay. Here. Yes? Okay. Well, looking at this one here, we know one of the equations we're going to have to find the restriction for is x plus 3. But our x squared minus 9 and x squared minus 6x plus 9 both need to be factored. Now, luckily for us, x squared minus 9 is a nice one in factoring because it's a difference of perfect squares, making it x plus 3 and x minus 3. Well, not quite. Into right. Minus 3. Now we also need to factor x squared minus 6x minus 9. 2 sets of parentheses. Since the third term is positive, the signs are the same and match the sign of the middle term. Minus and minus. Factors of x squared are x and x. 2 factors of 9, 1 and 9, or 3 and 3. Which one do we want to use? 3 and 3. We could check this if we want, but this is indeed the correct factors for this here. Now, even though we have many or several different factors, we only have 2 unique sets, x plus 3 and x minus 3. With our x plus 3, the first thing we would do is subtract 3 from both sides, telling us x would be negative 3. Well, that would cause the denominator to be 0, so x cannot be negative 3. The other one, we would add 3 to both sides, telling us that if x is equal to positive 3, we'd have a denominator of 0, so that would not work either. Let's go and put those away for now. Thank you. So our two restrictions for this here is, really, we can write it as one statement, positive or negative 3. Questions on our restrictions before we start multiplying? So, what are we going to need to multiply everything by? So we would need x plus 3 and x minus 3 for sure. Because with our x plus 3, x minus 3, for the one on the far right, the x plus 3 and x plus 3 would cancel. On the far left, x plus 3, x plus 3, x minus 3, x minus 3. So the two ends, this works out nicely. And in the middle, our x minus 3 would cancel with our x minus 3. But that other x minus 3 will not cancel with the x plus 3. So we have to multiply everything by a second x minus 3. Because since the middle expression had two x minus 3 terms, we have to actually multiply all of them by x minus 3 twice.
So all of the leftovers.
Yeah, because normally it's just been 2 and we've been good, but since the middle one had x minus 3 twice, we had to multiply it by it twice. So everything had to be multiplied by x minus 3 twice. And if you're not sure if you need it more than once, multiply it through that expression through it once and see, does everything cancel? If it does, then you only needed it once. Here, we did multiply through by x minus 3 once. It didn't simplify both of the middle expression, so we did it again. And what that left us with is 4x times x minus 3 is equal to x minus 1 times x plus 3 plus 2 times x minus 3 times x minus 3. We could, but we will need to distribute. Yeah. Because if this was some of the others where we were just simplifying and we're left with x minus 3 times x minus 3, writing it as squared is fine. But here we're going to have to multiply it back out. So it might be easier to keep track of our terms if we have it written twice. Any other questions? Now at this point here we can distribute. We can do 4x times x is 4x squared. 4x times negative 3 is negative 12x. Well, that's it for that side for a little while. Now the other side, x minus 1 and x plus 3, we're going to have to distribute the x. X times x is x squared. X times 3 is plus 3x. Negative 1 times x is negative x. And negative 1 times 3 is negative 3. Now we don't have to put parentheses around this because there's not a number in front of it. There's not a sign, a negative sign in front of it. There's no sign or number here, so we don't need the parentheses. We're not going to have to multiply by something after it. However, our second set has this plus 2 times our x minus 3 times x minus 3. So we'll multiply the x minus 3's together and then multiply what we get with 2. Questions on this here? I feel like we had x minus 3 and x minus 3 come from somewhere, didn't we? It came from what, R? Because x plus 3 times x minus 3 came from our x squared minus 9. But our x minus 3 times x minus 3 came from our x squared minus 6x plus 9. So we can go through and multiply it out. There's nothing wrong with saying x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is plus 9. Which will give us x squared minus 6x plus 9. And if we notice that one of our sets of multiplications came from something we factored to begin with, might as well just replace it. Now, if we didn't notice that, that's perfectly fine. And we did the entire multiplication out, like I did over here, we'd get to the same answer. We'd get to the same spot. This here just makes it a little bit quicker. Next thing we need to do is combine like terms. 3x minus x is plus 2x. And we also need to multiply through by our 2. 2 times x squared is going to be 2x squared. 2 times negative 6x is negative 12x. And 2 times our 9 is going to be plus 18. Questions on this here? Now at this point again, we can combine like terms. Our x squared and 2x squared give us 3x squared. Negative 2x minus 12x is minus 10x. And negative 3 plus 18 is plus 15. Questions on any of this here? Well, we have quadratic terms, so we need to get this equal to what? 0, yes. Now we can move our 4x squared and negative 12x over to the other side, or we can move the 3x squared, negative 10x, and 15 to the other. Well, I don't know about y'all, but I'm a fan of whatever is going to provide the least number of steps. Kind of easier to move 2 than it is to try to move 3. The only downside is that our x squared term is going to be negative, but that's fine. Because we can subtract the 4x squared, which will make our x squared term negative x squared. Then we can add 12x, telling us that 0 is equal to negative x squared plus 2x plus 15. Now at this point here, we can try graphing this. We can grab the graphing calculator. Y equals negative x squared plus 2x plus 15. We can type it in and hit graph. It crosses the x-axis in 2 spots. Negative 3 and 5. So it tells us the solutions are x is equal to negative 3 and x is equal to 5. Questions on this here? Well, either one of these are restriction. X equals negative 3 is one of our restrictions. So the only solution we actually have for this is x equals 5. Now, if we wanted to try factoring, I would have divided or multiplied everything by negative 1. And all that's going to do is just change the signs. Not plus. So for instead of negative x squared, it's positive. Instead of positive 2x, it's negative. Instead of positive 15, it's negative 15. And this does change some of the values. And I can graph it here and show this. And we can see the red graph is pretty much almost a flip across the x-axis of the blue graph. But negative 3 and 5 still have a y value of 0. It'll still have the same value. Does that make sense? So we can do that to get there. So if you're trying to factor it, the first thing I would do is factor out the negative. Then we'd have 2 sets of parentheses with 3 spaces. Signs are going to be opposite. We're going to have x and x, 3 and 5, plus 3 minus 5. A little far. And just tell us that x plus 3 is 0. Go to the other side, x minus 5 is 0. Here we would subtract 3. Here we're going to add 5, telling us x is equal to negative 3. X is equal to 5. And just like we said before, x equals 3. Negative 3 doesn't work. So it's just 5. Question on this here? Do you feel comfortable with these? Well, before we call it a week for this here, we're going to do one more. Now, one thing I will say with any of these here, whenever we're solving, even if the numerator is factorable, do not factor it. Because, especially with solving, if it was factorable, we had to multiply it back out. So if we did factor it, we'd have to undo it. Now, I'm going to go on and tell you x squared minus x minus 2 factors to x minus 2 times x plus 1. And I'm also going to go on and give you the restrictions. X cannot be 1, x cannot be negative 1, and x cannot be 2. So if we get 1, negative 1, or 2, it doesn't work. I'm going on giving you those because I feel like at this point, all we would do is x plus 1 equals 0, x minus 1 equals 0, x minus 2 equals 0. Solve for x's. So do we feel comfortable with this here? Also, I'm going to tell you, spoil this, none of those 3 numbers are going to be our solution. We're not going to have 1, negative 1, or 2. Well, what are we going to multiply everything by? X minus 1, x plus 1, and x minus 2. Multiplying by all 3 of these here. In the first one, the farthest to the left, x minus 1 and x minus 1 would cancel. In the middle, x plus 1 would cancel. And in the last one, our x plus 1, x minus 2 would cancel. Now, out of all 3 of these fractions, the one on the far right is kind of the nicest one out of the group, but we'll see that in a minute. Because what we have left is 2 times x plus 1 times x minus 2 plus 1 times x minus 1 times x minus 2. It's just really going to be x minus 1 times x minus 2. We don't have to write that 1 in. And the last one's 1 times what? Well, which is just x minus 1. That's why I was saying the one on the far right is kind of the nicest one out of the group, because it's just x minus 1. We don't have to do anything else to it. Now we're going to need to do some distributing. First one we're multiplying is x plus 1 and x minus 2. Wait. That one's kind of nice, isn't it? Because what's x plus 1 times x minus 2 going to be? X squared minus x minus 2. Yes. Because, well, we got it from factoring in the beginning, yes? I'm all for it. If we can find an easy way to get there, might as well take it. Plus x minus 1 times x minus 2. Well, we didn't factor anything to get there, unfortunately. So we're going to have to distribute this out. X times x is x squared. X times negative 2 is negative 2x. Negative 1 times x is negative x. And negative 1 times negative 2 is positive 2. Now at this point we can distribute the 2. 2 times x squared is 2x squared. 2 times negative x is negative 2x, and 2 times negative 2 is negative 4. Plus x squared. Our negative 2x and negative x give us negative 3x. Plus 2 is equal to x minus 1. Combine like terms. 2x squared and x squared give us 3x squared. Negative 2x minus 3x is negative 5x. And negative 4 plus 2 is negative 2 is equal to x minus 1. I didn't know if I'd noticed this before, but I did notice 6th hour. The 3x squared minus 5x minus 2 factors and factors pretty nicely. But we can't just factor it yet. We have to get this thing equal to 0. So the first thing we can move over is 1. We can add 1 to both sides. Notice that we have 3x squared minus 5x minus 1 is equal to x. Yes, we'd minus our x next, because we need to get this equal to 0. And the reason I said that it was factorable, because it was, the 3x squared minus 5x minus 2 is factorable. However, 3x squared minus 6x minus 1 is not factorable. But we can still solve this. The quadratic formula. We have to use the quadratic formula for this here. Now this is coming from our ax squared plus bx plus c. And for us here, the value of a is positive 3, the value of b is negative 6, and the value of c is negative 1. So what we'll have here is negative 6, plus or minus the square root of b squared, so negative 6 squared, minus 4 times our a value, which is 3, times c, which is negative 1, all over 2 times 3. We good? Okay. If you need me to slow down at any point, just say so. Now, some of this we're going to plug into the calculator. Some of this we can do without a calculator. Negative 6 is positive 6, plus or minus. The denominator, 2 times 3 is 6. Now we're going to simplify. Negative 6 squared minus 4 times 3 times negative 1. Oh, okay. Negative 6 squared minus 4 times 3 times negative 1 is 48. Now we're going to have to take the square root of it, so might as well go on and do that. It's 4 squared root of 3. We do it in the 30xs just to see if there is something that reduces if we can simplify that square root of 48. Root of 48. Well, it does simplify 2 plus or minus 4 square root of 3 all over 6. Questions on this here? We all caught up to this point? Last question before we can call this finished. Well, 2. Do the two numerators, 6 and our 4, and the denominator 6 have a common factor?
6.
Not quite 6. Just 2. I think that's you're the 4th person today. I think I've had that in every hour. And it is very tempting to say 6 because the 6 on top, 6 on bottom. But they do all have a common factor of 2 that we can reduce out. And if we reduce it out of the two numerators, take it away from 6, take it away from 4, we get 3 and 2. We comfortable with that? And if we take it from the denominator 6, we have 3. And that right there is our final answer. Okay. Now the last thing we can say, we just need to make sure this is more, as well as the answer is no, is that one of our restrictions? So that both of those work. Homework. 23 through 26, 29 and 30. I believe, if I remember right, 2 of these probably are going to need the quadratic formula for it. Yep. Give you all a minute here to write those down. I think so. Which one did you have a question on?
I don't know where to go from here. So like on the ones, because like I looked at the notes and they don't have it where it's like a factor of adding here.
Ah,
There's not.
okay. 2x plus 7. Okay. Number 7, yeah, 751. 751. So we would multiply both by the 2x plus 7x minus 1, and you did do that. On the left, 2x plus 7, 2x plus 7 would cancel. On the right, x minus 1 would cancel, leaving us with x times x minus 1 is equal to x minus 5 times 2x plus 7. Now at this point, we would distribute. X times x is x squared. X times negative 1 is negative x. Here, we're going to distribute x times 2x, 2x squared. X times 7 is plus 7x. Distribute the 5, 5 times 2x, and then, yes, 10x, and it would be negative 5, negative 5 times 7, minus 35. Now at this point, we can combine like terms. These up 2x squared, minus 3x, minus 35, yes? Well, we do have x squared terms, so we have to get this thing equal to what? 0. Well, the first thing I can subtract is x squared. I could have subtracted the negative, or added the negative x first. It really doesn't matter. We just have to pick one or the other. Because whichever one we don't pick, we do it next. Telling us that 0 is equal to x squared minus 2x minus 35. X squared minus 2x minus 35. Second graph, 7, negative 5 is one of them, and the other is 7. Yes. And we didn't list it, but our two restrictions were that x could not be 1 and x could not be negative 7/2.